Binomial distribution. We already know binomial distribution. We'll do once 1 over 4 plus 1 over 5 plus 4 over 5 to the power 3. 3c0 1 over 5 0 4 over 5 3 and 3c1 1 over 5 1 4 over 5 square and 3c2 1 over 5 square 1 over 4 over 5 1 and 3c3 1 over 5 cube and 4 over 5 0. This is 1 over 5 times 4 over 5 3, so this is 3 times, and this is 3c2 mean again 3 times. This is 1 over 5 cube and 4 over 5 0. 1 1 2 1 1 3 3 1 Pascal triangle 1 3 3 1. I'm going to discuss an example. I am tossing a bias coin. Probability of head is getting 1 over 5, not half as usual, and the variable x is number of heads. You count number of heads. So when we toss a coin, we know that we will get number of heads either. So I am tossing 3 times. Number of times is 3. So when we toss coin 3 times, sometimes we may not get at all. So this is the distribution. X is taken. This is the sample space. Not at all. Or 1 head, or 2 head, or 3 head. So this is the possibility. Then distribution is x 0 1 2 3. Probability of x equal x. We toss a coin 3 times, and the variable x is counting the number of heads. So we can work with this, the tree diagram. First head and tail. So getting head is 1 out of 5. This is 4 out of 5. Then again second toss, head and tail. Head, sorry about this, head and tail. So that is 1 over 5, 4 over 5, 1 over 5, 4 over 5, and again head, tail, head, tail, head, tail, head and tail. So 1 over 5, 4 over 5, 1 over 5, 4 over 5. This is as usual like GCSE. Now probability of getting a 3 head. 1 over 5 cube, and probability of this branch head, head, tail. 1 over 5, 1 over 5, 1 over 5, 4 over 5, 1 over 5, 4 over 5, 1. And this is when you go HTH, how many heads? 2 heads. Probability of HTH, you have 2 heads. This one, so 1 over 5 square, then 1 tail, 4 over 5. And this is head, tail, tail. Probability of head, tail, tail, 1 head and 2 tails, 4 over 5 square. This is tail, head, head. Probability of tail, head, head. So 2 heads there. So 1 over 5 square and 1 tail, 4 over 5. So I always write tail once other side. Probability of for this sum only. Tail, head, tail. Tail, head, tail, that is 1 head and 1 tail, 2 tails. That is 4 over 5 square. And then tail, tail, head. Over tail, tail, head. So this is going to be 4 over 5 square times 1 over 5. Then probability of tail, 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 that is 4 over 5 cube. Here I have 2 by 2 everything, so I will make to complete. I will write 4 over 5. I think I want to work out those two again. To other side. 1 head here, 1 over 5, and 2 tail, 4 over 5 square. This is 1 over 5, no 1 over 5s, and all are tails. This is only 1 over heads 3, 1 over 5 3, and no tail, 4 over 5 no. So all 1 over 5 is 4 over 5. That's how I match this one. Now we'll write when x equals 0, no heads. So what are the options? No heads mean this one, t, t, t. 1 over 5. So 0 number of heads, getting 0 number of heads is this one. 1 over 5. 1 over 5 0 and 4 over 5 3. 4. No heads, 1 over 5 0. Getting 1 head. 1 head is this one. I can see this is 1 over 5 HT T 1 over 5 1 and 4 over 5 square. Then one more, another one, THT 1 over 5 and 4 over 5 square. And this one TTH 1 over 5 and 4 over 5 square. And getting two heads. 2 head is going to be this one. PHTT 1 over 5 1 over 5 square and 4 over 5. And another one, yeah, HTH 1 over 5 square 4 over 5. And THH again 1 over 5 square and 4 over 5. Then get in 3, 0, 1, 2, 3. Get in 3 heads. So we pick up everything. The remaining one is 3 heads. 1 over 5 cube and 4 over 5 0. Now we can see that this is 1 over 5 0, 4 over 5 3, and this is 3 times 1 over 5 because 1 2 3, 3 times 1 over 5 and 4 over 5 square, and this is again 3 times 1 over 5 square, 4 over 5, and this is only 1, so 1 times 1 over 5 cube, 4 over 5 0. Now when you expand 4 over 5, we'll write actually we don't need this one. uh, so 1 over 5 3 times. This expansion we write the binomial 3C0 1 5. So I write the other way. It has to be other way around. 4 over 5 plus 1 over 5. So this is the success we need. 1 over 5 we need. Probability of head. So this is 3. 3C0 4 over 5 3 and 1 over 5. So I'm going to 4 over plus 1 over 5 to the power 3. Now we can 3 is 0, 4 over 5 3, 1 over 5 0, plus 3C1 4 over 5 square 1 over 5 1, and 3C2 4 over 5 1, 1 over 5 square, and the other one I will write 3C3 1 over 4 over 5 0 and 1 over 5 3. Now that is 3C0 is 1. So 4 over 5 cube 1 over 5 0, and this is 3 times 4 over 5 square 1 over 5, and this is 3 times 4 over 5 1 over 5 square, and this is 1 times 4 over 5 0 1 over 5 cube. Now I am adjusting bit that I will bring 2 times 3 is 3 times 2 both same. So I can adjust here 1 over 5 times 0, 4 over 5 times 3. I just interchange this one. 3, 1 over 5 and 4 over 5 square. And this is 3, 4 over 1 over 5 square, 4 over 5, and this is 1 over 5 cube, 4 over 5 0 to match with this one. That's what I did. Now you can see that these two terms are same. This one is same, this one is same, and this one is same. So the conclusion is this scenario is you can show by the binomial distribution. This scenario you can present by binomial distribution. Now you can see that um, bias coin the probability is 1 over 5. So we have four options. Either we get no head, one head, or two head, or three head. Then getting one head. One head is 1 over 5. So getting no head, 1 over 5 no. And then no heads, 4 over 5, 3. And getting two head, getting one head. So then 1 over 5 is 1. Then 4 over 5, the other outcome has to be, addition has to be 3. So then this has to be 2. Getting 1 over 5 two times. Then 1 over 5 square. And 3 over 4 over 5, 1. Addition is 3. Now this is 1, binomial coefficient 3, 3. And then the last one, 3 times. Then 1 over 5, 3. And 4 over 5, 0. Addition is 0. We'll do another discussion, another example. Before that, now you can see that we have two outcomes. One is 1 over 5. The other outcome is not head, which is 4 over 5. So basically for binomial, we should have clear two outcomes. 1 over 5, 4 over 5. Getting head, getting not head. So two outcomes. Instead of outcomes, we use two probabilities. 1 over 5, 4 over 5. Another example. So we are tossing a coin 4 times. This is a bias coin. Probability of getting head is 2 out of 5. Find the distribution. So we can start. So when you toss a coin, variable x is number of heads. So when we toss a coin, either we can take 0, no heads, 1 heads, 2 heads, 3 heads, and now 4 heads, because this is 4 spins. Now, first of all, what is the binomial coefficient? So 4C0, 4C1, 4C2, 4C3, 4C4. 1, 4, 4, I think. So 1, 4, 6, 4, 1. Or you can find NCR, you can remember. NCR is n factorial n over n minus r times factorial r. NC2 mean 4C2 mean 4 over 2 over 2. 4 times 3 and 2, that is 6. So 1 times 4 times 6 times 4 times 1 time. So probability of getting head is 2 out of 5. Now no heads. No head mean 2 out of 5 has to be 0. Then what is the other one? Tail or the non-head. 3 out of 5. So that has to be 4. And then 4 times we have that one. 1 2 out of is 1, and none heads. We 3 out of 5 is 3. 3 plus 1, 4. Done. So 2 heads getting. It means getting 1 heads 2 out of 5. So 2 times we get in square. Then 3 out of 5 is 2. Then this one 2 out of 5 is 3 because 3, and 3 out of 5 is 1, and then 2 out of 5 is 4, and 3 out of 5 is 0. So, we use a binomial distribution to find the probability. So we can find these answers. This is one probability x equal x, and now we can write this one, this variable in binomial as a distribution. So x follow binomial distribution, and number of trials is 4, and the required probability is 2 over 5. That's how we write the binomial distribution. The standard form is x is follow binomial, n mean number of tiles, and p is the probability. This probability has to be the probability of our intention. So here, or what we require from that variable. So we are expecting number of heads. So then the probability belongs to having a head 2 or 5. To apply this one, so we write the probability distribution as probability of x equal, this is the standard one, x equal r equal n c r p r, 1 minus p n minus r. This is the probability mass standard probability mass function, and we'll adapt to this one now because n we know n is 4, and p we know that is 2 over 5. So then probability of x equal r is still the same. N we know 4, c r, p we know 2 out of 5 r, and 1 minus v. So 1 minus 2 out of 5 means 3 out of 5. So 3 out of 5, n minus, n we know it is 4 minus r. Now, when we have this number of trials, and then when we have the probability, then we can write the standard probability mass function, and then we can find. So uh, now in here you can see x equal r we use, but if you want to use x equal x, it's still possible. P x equal x is nc 4cx 25x 3 over 5 4 minus x. It doesn't matter r or x when it's come to here. If you want to find this probability, you want to simply put r equals 0, x equals 0. So then you will get, okay, I'll put x equals 0 here. Probability of x equals 0 is 4c 0 2 over 5 0 3 over 5 4 minus 0. So that is 4c 0 2 over 5 0 3 over 5 4, which is this one. When x equal 1, probability of x equal 1, then 4c 1 2 over 5 1 3 over 5 4 minus 1. So 4c1 we know that value is 4. You can find this one, and 2 over 5 1 and 3 over 5, 4 minus 1, 3. So likewise, now using this one, you can write uh, the probability. I'm going to discuss one more example, and x variable follow binomial 5 and 2 out of 7. Write the distribution. Can you tell me a story for this? I can tell a story. Tossing a coin 5 times, tossing a coin 5 times, and for probability of getting head is 2 over 7. So this is the scenario for this. Now you know how to do it. 0, 1. So there are 5 options. Either you can get 0, 1, or 2, or 3, or 4, or 5. Then the binomial probability 1, 1, 2, 1, 1, 3, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So this is 1 times, 5 times, 10 times, 10 times, 3 times, 1 times. Then you know the probability 2 over 7, 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 2 over 7. So 0, 1, 2, 3, 4, 5. Then what is the 1 minus 2 over 7? 5 over 7. 5 over 7, 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 0, 1, 2, 3, 4, 5. Now, we'll write this one in the binomial probability mass function. Capital X, this is going to be simple x, px equal x. Now, the standard one is probability of x equal r is NCR over PR 1 minus P n minus R. So then if this is x, I will take away Px over x is NCX Px 1 minus P n minus x. So then I have the one Px equal x NCX Px 1 minus P n minus x. Now x equals 0, P probability of x equals 0 probability x0 equal sign nc0 p. What is the p value now? Okay, so now we have to define p. N equal 5 number of trials, and the required probability is 2 over 7. So this is going to be 4c0. Okay, I will standard customize this one 4, and n has to be n has to be 5 and 5. Now it is, and p has to be now 2 over 7 and 1 minus probability of x equal x is p ncx px 1 minus px. So this is going to be probability of x over x. N is 5, c x, p is 2 over 7 x, and 1 minus p is 5 over 7 n minus x. N minus x. N is 4. Now we can write x equals 0 p, x equals 0, 5c 0, 2 over 7 0, 5 over 7, 4 minus 0 is this one, 5 0 is 1 times 2 over 7 0, 5 over 7 4. So this is going to be 2 over 7 0, 5 over 7 4. Then p x equal 1, 5c1, 2 over 7 1 and 5 over 7 4 minus 1. So this is 5c1 is 5, 2 over 7 1 and this is 5 over 7 4 minus 1 3. So then this is 5, 2 over 7 1 and 5 over 7 3. So likewise you can write by using this. Now I'm going to change this one. I'm going to put 100 trials and the same probability. So n equal 100, and I want to know that x. I want to know that number of 7. So this value probability of getting p x equal 57. So what is the formula for this one? P x equal x is NCX Px 1 minus P n minus x. So now I know that x value is going to n is 100. N is 100, so we'll customize this one. X, this is 100. Cx P is 2 over 7. Okay, I'll change this to 3. 3 over 7 x. Then this is 4 over 7 1 minus v, 100 minus x. Now I want to find probability of x equal 57. 57 times getting head. So then I want to put here x equal 57. So probability of x equal 57 equal 100 c 57, 3 over 7 57, 4 over 700 minus 57, which is 100 c 57, 3 over 7 57, and 4 over 7 100 minus 57 43. 43. Now how do you find this one? So you can find from the calculator. I am using Casio in Casio FX991EX. Um, you can see with the division on top of, you can see NCR symbol. So what we could do, you can type 100, then shift, then division sign, press 100, then division sign, and then so you'll get 100, then division sign when you get 100C, and then press 57. So 57. So then 57 you will get 100C 57. Then you have to normal write in. So after that 100C 57 multiply by 3 over 7, you know how to write this one, to the power 57 multiply by 4 over 7 to the power 43. So you will get the answer. Uh, and if we can re- represent event by binomial expansion, so we know that we discussed we can write like this. In there are when we apply these tests has to be done. There are fixed number of trials. There are fixed number of trials and two possible outcomes. So the previous one we had 100 trials. We did 103 over 7, I think. So 100 is fixed amount. Then two possible outcomes. Possible outcomes in one is success and failure. So when we take number of heads, there are two outcomes, getting head and the failed one not getting head. So two outcome, probability of getting head or probability of getting not. So this is going to be 3 out of 7, and the other one failure is let's say tail, that is 4 out of 7. And there's a fixed probability of success P. There is a fixed probability of success P. I'm writing the same thing in 88 page. There is a fixed probability of success P. So now this P 3 over 7, always that is not going to be a change. And the trials are independent. Trials are independent. So 1, 2, 3, 4. So those are the assumptions you need to explain when you apply a binomial expansion to an event to find the binomial probability. I'm going to discuss one last sum, uh, that is assume the production, so the pen production, and from a factory, and probability of getting defective pen is 0.4. So our interest is defective. So our interest is defective pen. Then probability has to be probability of defective is 0.4. Then I am buying 5 pens of this one from a shop, or I'll order 5 pens from this factory. So the number of trials n equal 5, and I want to know the probability of getting. I want to write the distribution of the defectives. Distribution of the defectives. When you order, so this is D, probability of, I will write this is X, X equal X. So for X can be, I can get one defective, no defective out of that, one defective, two defective, three defective, or four defective, 5 defective. So now you know how to write the probability. 1, 5, 10, 10, 5, 1. Or you already know that. I want to show how to do from the calculator. 1, 5, 10, 10, 5, 1, and defective 0 0.4, 0 0.4, 0 0.4, 0 0.4, 0 0.4, 0 0.4. This is 0, 1, 2, 3, 4, 5, and 0 0.4. That is p value is 0 0.4. So then 1 minus p is 1 minus 0 0.4, 0 0.6, 0 0.6, 0.6, 0.6. Okay, 0 0 0.6, 0 0.6, 0 0.6, and this is 0, 1, 2, 3, 4, 5. Now we wrote the distribution. Now we need to calculate this one. This is times. You want to calculate this one. We'll see how we can do from the calculator. So we'll do this Casio fx 1 1. So x equal fx 991 dx. So on, when you on the on, then menu enter, and then 7 enter. Yeah, when you press 7 you will get 4 options, 1, 2, 3, 4. Just go to the 4 binomial. So we want to go binomial, so press 4. Then we have two option, 1 and 2. So go to list, press 1, press 1. Then I need you can see two columns, x and p. So x value is 0, 1, 2, 3, 4, 5. Now press 0, 0 equal 2 equal 3 equal 4 equal 5 equal. I may say actually you have to do it again. 1 equal 2, 3, 4, 5. Do by deleting whatever you enter if you enter. Now you can see in your column 0, 1, 2, 3, 4, 5 like this, and then press one more equal sign, then you will bring to the binomial PD. Binomial PD, they will ask in number of trials 5, we did for 5, and probability is going to be 0 0.4. So you have to type this one. So 5 enter, 0.4 enter, and then finally press equal sign. Then you will get the list of numbers like this. So I will write x value 0, 1, 1, 2, 3, 4, 5. So you should get these numbers. So hope I did it properly. So 0 0.007, this value is 0.007. This value is going to be 0.3456. This is 0.2304. This is 0.0768, and this is 0. 1, 2, 3. Did I miss? Yeah, I missed one. So 0.2592, 0.3456, 0.2304, 0.0768, 0.0102. Now I'm going to find the cumulative probability, this one, F. So this is 0.0007 when you add this one. So when I add 7 to here, 7 plus 2, 9, and this is 9, 5, 2, 0. Then I want to add those two, 9, 6, 9, 6, 5, and 9, 5 plus 4. So I will add and write. This is going to be 0.6055, and then I will this one plus this one. So I'm going to add those two and write here. I think I made a mistake here. This is 0.777 and others right, so I had to recalculate everything. So I wrote the numbers again. So I add this one plus this one plus this. Likewise, this is the cumulative probability. Now if you go to page 204 on the book binomial distribution function, you can see the chart. You can see P here, then some 0.05, 0.10. Likewise, you can see like this. So this is, you can see n equal 5 and x equal 0, and n equal 6, x equal 0. So you can go to because I select 5 trials, so this has to be a 5, and then you want to go to 0.44. You can look at the 0.4 values. Then you can see here 1, 2, 3, 4. If it is 6, here 1, 2, 3, 4, 5. 6 is missing. Here 5 is missing because it is obvious that it is add up to last one is 1. So that's why they don't write. Now you can see if you go to P 0.4, first of all select n equal 5, and then P equals 0.4. You can see that these numbers, this is 0.77 when we approximate 0.778 here, 0.778, and 0.3370, and 0.6826, and 0.9130, and 0.98, 98, but you can't see one, so you have to, the fifth one they don't give, so it is fifth, you have to assume. So that's how this table is fixed. Now you can see that the idea behind that table. So if you want to find the probability 0.1 and the number of trials 5, so probability, for example, x follow binomial and 5, and that is 0.1, then you have to select this one, but it is in the cumulative form. Now for example, to find probability of x equal 3 on here, you want to find from a cumulative, so you want to get this one 0.930, and then you minus this one 0.6826, then only you can get 3, because in here up to in this table, so this is probability of x equals 0. This is probability of x equals 0 plus probability of x equal 1. This is probability of x equals 0 plus probability x equal 1 plus probability of x equal 2. So this is same as x equals 0, x equal 4, and x equals 0, 1, 2, and 3. And this one is going to be probability of x equals 0 plus probability of x equal 1 plus probability of x equal 2 and probability x equal 3, and this is probability of x equal 4. Now if we want to find, so those are the numbers. Now if we want to find probability of x equal 4, so now this is probability of x equal 0 plus uh, x equal 1 plus probability of x equal 2 plus probability of x equal 3 plus probability of x equal 4 and probability of x equal 5. Now if you want to find probability of let's say x equal 5, then you want to minus probability of x equal 4 minus probability of x equal, okay, this probability actually we are writing like this. This also something you need to know. This probability we are writing probability x less than x equals 0. Then probability x less than or equal to 1. So the same thing we are writing in one way. Probability of x equal to 2, less than or equal to 2. This, instead of writing these three terms, I can write this. So probability of x less than or equal to 3. Probability of x less than equal to 4. So probability of x less than or equal to 5. Then if you want to find probability of uh, x equal 4, then you want to probability of x less than equal to 4, this value, minus probability of x less than or equal to 3. Then only you can get the right value for 1. So 0.9898 minus 0.9130. Then only you can get. So from the calculator you can get the x equal 4 straight. But if you refer the table, in this table it is in the cumulative form. So then you have to get the particular one, you have to minus that one from the below one. Another one, probability I want to find x equal, simple one, x equal 2 or x equal 1. Now you can see 0 and this is 0 plus 1. Then you have to minus probability x less than or equal to 1 minus probability of x less than or equal to 0, or this is a, since this is first one, x equals 0. So then 3.3370 minus 0.0778. Another one, probability of x equal 3 you want. Then probability of x less than or equal to 3 minus probability of x less than or equal to 2. 3, so 0.9130 minus this one 0.6826. Then only gets x equal 3. So this is if you refer the table. Otherwise you can use the calculator.